Welcome to Homework Lib.
For this problem, we have the decomposition of NO2 into nitrogen monoxide and oxygen. The reaction is simply 2 moles NO2 goes to 1 mole NO plus O2. It then provides data showing the concentration of NO2 as a function of time, and it wants you to determine the order of the reaction with respect to NO2. To do this, you need to plot the concentration of NO2 as a function of time, the natural log of the concentration of NO2 as a function of time, and 1 over the concentration of NO2 as a function of time. If it is zero order, then the concentration as a function of time will give you the best straight line. If it's first order, natural log of concentration as a function of time will give you the best straight line. And if it is second order, 1 over the concentration as a function of time will give you the best straight line. So I went ahead and used the data that was given, which would be these numbers here. In Excel, I calculated the natural log of the concentration. I also calculated 1 over the concentration. I then plotted concentration as a function of time, as shown down here, and then 1 over the concentration, natural log of the concentration as a function of time, and 1 over the concentration. If when you're plotting and preparing these curves in Excel, after plotting using XY scatter without connecting the dots as the graph choice, then you can right-click on any one of the data points and add a trend line. When you add the trend line, there will be a linear line that attempts to best fit the data points, as shown for each of these. And hopefully you can tell that the data points best fit this straight line versus the other two. However, sometimes it is difficult. And what you'll want to do is, after you've added the trend line, you'll want to modify the trend line, and there'll be a box that you click for include equation of the line and include the R-squared value. The R-squared value is a statistical value that describes how well the data fit the best straight line. And the closer this value is to 1, the better the data fits the straight line. So, of the 3 graphs, the 1 over concentration as a function of time gives us the best straight line. Therefore, it is second order. With second order, the K value, the rate constant, is simply the slope. So in this case, the slope and the K value is 10.16. Because it's second order, the units will be 1 over molarity time. This then answers Part A and Part B. Part C asks you to predict the reaction rates at the beginning of the reaction for initial concentrations as provided. Well, now that we know that it's second order, then rate is going to be equal to the rate constant, which we just determined, multiplied by the concentration of NO2 squared. So for the first one, we have a concentration of 0.2 molar. So rate will be equal to 10.16 multiplied by 0.2 squared, which gives us 0.4064 molar per second. For the next one, the concentration is 0.1, so we'll plug that in with the rate constant and square the 0.1, and we get 0.1016 molar per second. As you might guess, as we double the concentration, because it's second order, we should be quadrupling the rate, which is what we are seeing. Then for the last one, rate is going to be equal to the rate constant multiplied by 0.05 squared, and we get 0.0254 molar per second.